Welcome to Super Easy Physics and Mathematics, CPAM. Get ready as Mr. Matthew review IGCSE Physics Paper 2, Variant 2, October-November 2022 with you. You have a lot to benefit as you actively watch this video. Let us get part 1 started as you pay keen attention. Question 1. Which measuring devices are most suitable to determine the volume of about 200 milliliters of liquid and the diameter of a thin wire?
You use measuring cylinder to measure the volume, and then you use micrometer screw gauge to measure the diameter of the wire. This micrometer screw gauge is used to measure the outer diameter of the wire.
Question 2. The diagrams show speed, time graphs for 4 different bodies moving for 6.0 seconds. Which body traveled the least distance?
So the basic fact we need here is that for velocity time graph, speed time graph, the distance traveled by the object is equal to the area under the curve. So for the option A, the area of this triangle, height of 8 and base of 6 will give you 24 cm. For this, we have two triangles. The highlighted one and this other one that is not highlighted. This is 4 by 2. So add everything together, 20 meter. Then for option C, the area under this shape, so this is a rectangle, 8 by 6, 48 meter. Then for option D, you have 8 by 4. I divided the curve into 2 sections, 2 rectangles, 8 by 4, and then 4 by 2. So the least is D.
Question 3. Which statement describes the relationship between mass and weight? Question 4. The diagram shows 4 pieces of laboratory apparatus: balance, measuring cylinder, ruler, and stopwatch. Which pieces of apparatus are used to find the density of a liquid?
So formula for density is mass of the object of the liquid divided by the volume of the liquid. So to measure the mass of the liquid, you use the balance. Then to measure the volume of the liquid, you use measuring cylinder. So the option is the combination of balance and measuring cylinder, B.
Question 5. The diagram shows a meter rule MN on 2 supports, P and Q. 2 loads are placed on the rule, as shown. The rule rests steadily on the supports. Which row is correct?
First of all, we have to look at the condition for equilibrium. when is a system said to be equilibrium? So the total upward force, the total force, the force acting on the support P, the reaction on Q must be equal to the weight of this load down and the load of this load down. Then the second condition, the total clockwise moment, that is if we are going to pivot it on M, the clockwise moment on it must be equal to the anti-clockwise moment if the beam is free to move up and to move down. But in this case, it is not moving. So the movement here to clockwise is 0 and the movement up is 0. Then no net force acting on the support. So if there is no net force acting on the support, that means the total force that is acting will balance out in each direction. So the net force in each direction, another way of putting this one, that the net force, directional net force is 0. Then the support is not moving. So if it's in equilibrium, the support is not moving, the beam is not moving. So based on that, the correct option is D. Total clockwise moment is 0 and the total moment on N is also 0. So that is the one that is correct for the support to be stable.
Question 6. The diagram shows an object moving at a constant speed in a circular path in the direction shown. A force acts on the object to keep it in the circular path. In which labeled direction does this force act when the object is in the position shown?
So let's analyze what each of the direction is representing. Direction A represents the direction of motion, the linear velocity point in this direction. And you discover that object moving in circular path always experience acceleration because the linear velocity is constant, but the direction of the velocity varies with each position. So that is what is responsible for the acceleration of the object on the circular path. B represents the centrifugal force, while C represents the drag force acting on the object moving, the frictional force due to air resistance, and D represents the direction of the centripetal force. And for this object to remain on this circular path without varying or altering it, D is the force that balances the object in this position. Then the value of the centripetal force is equal to the product of the mass of the object and the square of the velocity of the linear velocity divided by the radius of the circular path. So the centripetal force is mv squared divided by r.
Question 7. A trolley of mass 4.0 kilograms traveling with a velocity of 4.0 meter per second collides with a trolley of mass 2.0 kilograms traveling with a velocity of meter per second in the same direction. After the collision, the velocity of the 4.0 kilograms trolley is reduced to 3.0 meter per second. What is the velocity v of the 2.0 kilograms trolley after the collision?
So we are going to apply the law that is collision, total momentum before collision. The momentum of trolley A, I'll call this A and B, and is equal to the total momentum after collision, trolley A and B. So let's do that. So the mass of A multiplied by the velocity of A plus the mass of B multiplied by the velocity of B is going to be the mass of A multiplied by the velocity of A, the final velocity, then added to this velocity. So substituting so the final velocity will give us 4 meters per second. B, which is the correct answer.
Subscribe and we will help you to easily upgrade your performance to an A+.
CPAM is the solution to better grade.
Question 8. An object falls towards the Earth's surface. What happens to the gravitational potential energy and to the kinetic energy of the object?
So we are interested in the gravitational potential energy and then what happened to the kinetic energy of the object. Let me show an illustration of the motion. So you can see it's going down, kinetic energy increases. As it's rising, potential energy increases. So based on that, as it's going down, the potential energy decreases and the kinetic energy increases. So B is the correct answer.
Question 9. A boy takes 0.60 seconds to lift a book of mass 0.60 kilograms from the top of a desk and place it on a shelf. The top of the desk is 0.80 meter above the floor, and the shelf is 1.7 meter above the floor. The gravitational field strength is 10 Newton per kilogram. Which power does the boy develop?
So we want to look at, we are lifting the load from this location, top of this desk to the top of this shelf. So we know the difference in height. So he lifted through the height of 0.9 meter. So with that, we can calculate the power. So the power is equal to energy over time. That will give 9 watts. So the correct answer is C.
Question 10. A mass is lifted from rest on the ground to Y. There is no air resistance. P is the increase in gravitational energy of the mass. Q is the kinetic energy of the mass at Y. Which expression is equal to the mechanical work done on the mass?
So we are looking at the total energy of the system. So the total energy is going to be the summation of the gravitational potential energy and the kinetic energy of the mass at a given point in time. So we are going to look at, so Y is when you lift up the object, there's an increase in gravitational potential energy, and then there is also, the object is also going to gain velocity at this position Y. So the kinetic velocity, as in the velocity when you lift it up. So the total energy of the system is going to be the gravitational potential energy plus the kinetic energy of the mass at Y. So A is the correct answer.
Question 11. The diagram shows a tank containing seawater. The density of the seawater is 1020 kilograms AM3. What is the pressure at point P relative to atmospheric pressure?
So we should know that the pressure, atmospheric pressure, is the pressure at the surface. So we'll call that PA. But we are looking for the pressure at this position, at this depth here, 60 cm from the base of the tank. So for you to get that, we need to calculate the difference in the height, in the depth of the water. So if you calculate the depth of the water, so that is 7.4 meter deep. So at this depth, the total atmospheric pressure, the pressure under liquid is going to be the pressure at this point P plus the atmospheric pressure. So let's calculate the pressure. Pressure under liquid is density multiplied by strength of gravity multiplied by the depth of the liquid, the seawater. So with that calculation, the pressure is about 75,480 Pascal. So approximately to two cylindrical figure, that will be 75,000 Pascal. So plus the atmospheric pressure at the top. So the correct answer is C.
Question 12. The pressure of a fixed mass of gas in a cylinder is measured. The volume of the gas in the cylinder is slowly decreased. The temperature of the gas does not change. Which graph shows how the pressure of the gas changes during this process?
So we're going to use Boyle's law. And Boyle's law says that the pressure of a fixed mass of gas is inversely proportional to the volume. And based on that, that means as the volume reduces, pressure increases. So as volume decreases, pressure increases. So based on that, but take note, it said the pressure of the fixed mass of gas is measured. So the gas had pressure at the beginning of time, at the beginning of the experiment. So if you look at them, there are only two options here, B and C, which have increasing pressure. But B is wrong because B is saying that the gas has no pressure before the volume was decreased, which is not correct. So if there was gas inside the container, there will always be gas pressure. So B is not correct. So C is the correct answer.
Question 13. Wet clothes are hanging outside to dry. What are the best conditions for the clothes to dry most quickly?
So let's look at the factors affecting evaporation. Increase in wind, increase in temperature will make the evaporation to be faster. Larger surface area exposed of the clothes. Then the liquid that is used for washing the clothes, since it's water, so the volatility of the liquid. Those are the major factors. So if we look at them, which of them? The wind and temperature. So we say that if the wind increases, if the temperature is raised, then the rate of evaporation will increase. So for A, that is a correct answer that will make the clothes to dry quickly. So A is the correct answer.
Question 14. Which change in the design of a liquid in glass thermometer makes it more sensitive?
So we are interested in making it more sensitive. So if you look at that, there are four options here. A large liquid reservoir, yes. Long tube, no. Small liquid reservoir, no. Wider tube, no. So let me just show you the picture of a thermometer. So we have this reservoir here, the liquid reservoir, that is this portion here. Then you have the narrow tube that the expansion will follow, that is calibrated. So for you to make it more sensitive, if you have a larger reservoir here, you have more liquid that can easily expand through this. Or another word, we'll look at the sensitivity, the heat capacity of the liquid that is used to fill the reservoir. So that's another factor, but it's not part of the option given here. So if to make it more sensitive, when you fill it with a material that have low heat capacity, so it can easily detect the temperature difference, and then the rise will be rapid. Then we have this other option here. The difference between this one is that this blue thermometer has a wider tube, while this one has a narrow tube. So the correct option is A.
Question 15. A scientist is determining the specific latent heat of vaporization of a liquid. He puts the liquid in a vacuum flask and heats it with a 100-watt heater. The mass of liquid in the vacuum flask when it starts to boil is 300 gram. He continues to heat the liquid for a further 12 minutes, up to which the mass of the remaining liquid is 100 gram. What is the specific latent heat of vaporization of the liquid? Assume that all the thermal energy from the heater is used to vaporize the liquid.
So let's assume that he put the 300 gram of the liquid inside the vacuum flask. So let's just put in this container, and then he decided to use the heater to supply heat. So the heat supplied by the heater is equal to the heat gained by the liquid in order for it to convert from liquid to gas, which is the latent heat of vaporization at the boiling point. So for us to do that, we know that the thermal energy supply is going to be the power of the heater, 100 joule per second, supplied for 12 minutes, multiplied by the time, 12 minutes. So this 12 minutes, we need to convert it to second. So that will give the total energy supplied is 72 joules. This 72 joule is going to be the heat absorbed by the liquid in order for it. So it will use to evaporate it. So 200 gram has been evaporated. So the mass of liquid left is 100 gram. So the heat gained by the liquid is equal to the mass of the liquid multiplied by the latent heat of vaporization. The latent heat of vaporization is the quantity of heat needed to convert a unit mass of liquid to gas at its boiling point. So now we say since all the thermal energy supplied by the heater is used to vaporize the liquid, so we can equate these two values here. Heat supply equal to heat gain. So that brings us to this next level. Heat supply equals to heat gain. So if you have that, you are looking for the unknown parameter here, which is the latent heat of vaporization. That brings the value to 360 joule per gram. But if you look at all the options given to us, the value is not there. So what we need to do is to convert this value to joule per kilogram. And how many grams make 1 kilogram? That is 1000 grams. So you divide this value by that. So if you divide it, so convert it to gram, divide it by 0.001 kg. So that brings the value to 360,000 joule per kg, which is D. So that is the correct answer to this question. So that brings us this is the end of part 1. Go to part 2 to continue question 16 to 30. Thank you for reviewing this past question with me. Subscribe to Super Easy Physics and Mathematics. Share the video with your friends.
Subscribe and we will help you to easily upgrade your performance to an A+.
CPAM is the solution to better grade.